Okay, this is also from section 3.4. It's solving radical equations or equations with radicals in them. Okay, so the basic steps I typed up for you. The first one is isolate your radical. Get it on a side all by itself. If it's a square root, then you're going to square both sides. If it's a cube root, you'll cube both sides. If it's a fourth root, you'll do both sides to the fourth power, etc. Then, of course, solve your equation, and then you must check your answer. You have to make sure that the radicand, that's the number underneath the radical, is in the domain, and that for even roots, square roots, fourth roots, whatever, the answer is not negative. And I'll show you an example of that. So, and always when you check in the original problem, not when after you've isolated, but always check in the original. So here we go. All right, example number 1, you need to isolate the radical, so I'm going to add 3 to both sides. So I'm going to add 3 to both sides, and I end up with the square root of 2x plus 1 is equal to 6. And now I'm going to square both sides because it's a square root. So I'm going to square both sides. It's the square root of 2x plus 1 and 6 squared. And I square it because a square root squared is just the radicand, just 2x plus 1. That's why we square it, because they are inverse operations, so it undoes each other. And then 6 squared is 36. So subtract 1, 2x is equal to 35. So divide by 2. X is equal to 35 over 2. Not a very nice number, but we're in college, so it's okay to have crazy square roots. All right, so now I look at that and I say, all right, is that even possible? So if I check it, I check it in the original. So the original was the square root of 2x plus 1 minus 3 is equal to 3. So now I'm going to put in my 2 times 35 over 2 plus 1 minus 3. Does that really equal 3? Well, 35 over 2 times 2 is just 35. 35 plus 1 is 36. So the square root of 36 minus 3, does that equal 3? Does 6 minus 3 equal 3? Yes, it does. So that's what I keep. So I have to make sure that that's all working, okay? Because sometimes we end up with extraneous roots, as we call them, because we're squaring things. All right, so that was the first example. The second example, right here, I need to isolate my radical, so subtract 4, and so I end up with the square root of x minus 1 is equal to negative 4. And right here, I can quit, because when we solve radicals with equations, if we never ever use this secondary root, the square root is equal to a negative number. We always just want the positive root. So right there I can quit and I can say no solution. No solution. Okay? All right. Example number 3. The radical is already isolated, so I'm going to square both sides. The square root of 2x plus 5 squared is equal to x minus 5 squared. Now, you're squaring that binomial, so be super careful. Remember, x squared, if you have to write it twice, but don't forget that middle term, minus 10x, and then plus 25 here. And if I square the left side, I just get the radicand, 2x plus 5. So now I have to, it's a quadratic, so I need to make it equal to 0. So minus 2x minus 5, minus 2x minus 5. So I end up with 0 is equal to x squared minus 12x plus 20. Now, you should be able to factor these. They're not going to give you ones that are square roots, so when I factor this, I'm going to have both of them are minus. and it's going to be 10 and 2. That's going to give me my 12. So x is either equal to 10 or x is equal to 2. But remember, you have to check in the original to make sure that it's possible. So the original is the square root of 2x plus 5. Let me do that over here. The square root of 2x plus 5 is equal to x minus 5. And I need to check both roots. So if I do 10, the square root of 2 times 10 plus 5, does that equal 10 minus 5? And 2 times 10 is 20, plus 5 is 25. So does the square root of 25 equal 5? The answer is yes, so that's okay. How about 2? The square root of 2 times 2 plus 5, does that equal 2 minus 5? Look at the right side. That's going to be a negative 3. I can quit right there because my square root, remember, we're not taking those roots, so that's a no-go. So we throw away our 2, and we end up with just x equals 10. Okay?